Okay, so we're going to go through example 3 where we're going to use that angle side idea to prove that these two triangles are congruent. We're going to complete a proof that says so. So we've got some given information that line segment RQ and ST are congruent. So RQ, ST, these two vertical lines are congruent, and RQ is parallel to ST. Okay, so they're parallel and they're congruent. That is all we know at the beginning. So given that they are parallel, what can we say about angle RQS and angle TSQ? So RQS is RQS, so it's this guy here. So RQS is here, and TSQ is here. Well, can you identify out of these right here which one of these would describe what kind of partnership these two angles have with each other? What is their relationship to each other? So are these two vertical angles? Are they directly across from a vertex? I would say no. They're not exterior angles. They're inside these shapes. But I think we can say because of the alternate interior angles theorem. Abbreviate that. Alternate interior angle theorem, which states that the alternate interior angles are always congruent, would mean that these two angles must be congruent. Okay, I'm going to erase all that because that's messy. Okay, so then looking ahead to the next one. Looking ahead to the next one, we're given that RQ and S2 are congruent. And this description of the vertical angles theorem. So thinking about vertical angles here, the only pair of angles with these two triangles that would be considered vertical angles directly across from a vertex, I think is going to be these two. So it should be that RUQ is congruent to SUT, which is going on right there. RUQ congruent to TUS. Okay, so that would go into that box. That's the vertical angles theorem happening. And angle side, once we have, so let's look at this, we have two angles, the blue angle and the pink one, or purple one, or whatever the color is, and they match the blue and purple in this one. So we have two angles, and additionally, do we have sides? Well, yes, we have sides. We were given the idea that this side is congruent to that side. Okay, so we've got an angle, and a side. And the other triangle, we have an angle, and a side. Okay, so that means that the entire triangle, RUQ, must be congruent to the entire triangle, SUT. Okay. So don't get thrown off on my arrows. These arrows are kind of a flow of ideas. They say, given this must be true. Given these two things, this must be true. My arrows are just placing the proper vocabulary words in the proper spots. Okay. All right, and I think that is it for example number 3.